Alright, so the topic of today is a library in Python. It's called Turtle Graphics. It's a cute metaphor. It's going to help us draw cool stuff. It'll be very fun. But we'll work our way up to that. So I have one example before we get there. So yeah, feel free to open your idle program right now if you'd like to follow along. Remember, it's idle. It's not Python. You say idle, that's the thing that's going to let you edit files and run them. So we were in a REPL. Beautiful. So before we get to turtle stuff, which I'm very excited to teach you about, let's just give an example, just combining a bunch of stuff we learned before from the previous Python lecture. Just going to remember it all, and then we can do cool new stuff. All right, so let's make an example that has, we're going to get something from the user, and we're going to take that and convert to numbers, because when we get things from the input function, remember we get it back as a string, a str. Those words sound familiar, hopefully. And then let's do something to the numbers that we convert. All right, so let's ask the user for two things, and so we're going to get two numbers from the user, and I will draw those. So it'll be like, hey user, enter num1 and enter num2. And we'll compute the first number to the power of the second number. Okay, so let's see here. We're going to take these two numbers, we're going to get them. If you use the input function, remember that you're going to get them as strings, which is not useful for mathematical stuff. You're going to have to convert those to real numbers. So the real number 2, the real number 3. And our goal is to calculate 2 to the power of 3 if those are the two numbers the user types. So we'll just output 8. All right, so remember that in Python, to take something to the power of something else, it's the double star, 2 star star 8, or 2 star star 3, I guess is what I wanted. And yeah, that'll be how that works. And this might bore you a little bit. The turtle library is going to be great. It's going to be really fun and powerful. But our programs are just straight lines right now. We haven't learned how to condition. We haven't learned how to loop. We'll get all that stuff soon. But we're busy learning a new way of speaking programming. So I have to start slow again. All right. So we're going to have to write some simpler programs for a while. And then also, just I want to say this now so that you I get your expectations in the right place. It's going to take more code to write the same Python program than an equivalent Scratch program. All right, I hope that makes sense, because Scratch is supposed to be easy, meant for your first language. But in Python, you're going to spell out exactly what you want. There was no concept of types, for example, in Scratch, but that is suddenly here shouting at us in Python. So there's that. We call Python a bit of a more low-level language. Okay, Scratch is a higher level language. Python is a lower level language. It's closer to the processor. Right, so we have to speak it in a fancier way. Okay, so yeah, let's get the two numbers from the user. And remember, we're gonna ask for those things with the input function. Be like input, and then we get a little prompt. Hey, enter your first number, colon space, and they get to see that little prompt as they're typing, and then we get back that answer as a str. Right? Remember that. So we're getting 42, the string 42. And so if I want to actually get these numbers immediately from the user and have them be numbers, I better convert them. So call your input function, output your little prompty prompt, and then convert it immediately. Whatever you get back from the input function, convert it to an int, or convert it to a float, whatever you want it to be, your numeric type, and then shove that in a variable, num1. Okay? So that's the kind of syntax that's very common to see. Right? You get your input function, it gives you back a str, then you immediately take that and throw it to the int function, which will convert it to an integer, which is what we want. All right, so let's assume we're getting whole numbers from these, and that'll work. So I'm going to make a new file, new file. There's a new file with Python code inside of it eventually, and I'll save this in a place that I can find again. So I'll save it in a folder for today's lecture. You can save yours wherever you like, but let's see what lecture number we are. We're lecture 14. And I'll call this, we're taking something to the power of something else, and so I can call this power.py or pow.py for short. Some people abbreviate power computation as pow. Other languages do that, so it's what I'm used to. I'll call it pow.py. All right, so I'm going to get two numbers from the user, in this style, right? In this style, immediately converting them to whole numbers. Right? So let's spell it out in comments to get the first number from the user as an int. And so we're going to be like, all right, we're going to call input. That's like the thing that we're doing, right? We're going to ask the user enter the first number, colon space, because they're going to see that as they type. And so input gives me back the string that the user gave me, so I better save that somewhere eventually, like into num1. But I don't want to save the string. I want to save the number that the user really typed, not in the string form, right? I want to save not the quotes 42, but the number 42. So I'll just take whatever input gives me back and send it off to int, which knows how to make an integer out of a string. All right? So that's the first one. Then we'll do the same for num2. We'll get the second number. Get the second number from the user. Second. And we'll call this num2. Right? So now, after these two lines have run, then I really do have these two blocks up here, these two boxes in memory, num1 and num2. They exist. And what do we want to do? We want to calculate the first number to the power of the second number. So num1 to the power of num2. Calculate num1 to the power of num2 and print the result. Remember that in Python, it's not the caret character, that is the power. Right, it's double star. So print, like, the result is, and I'll just use multiple arguments for the print function so that I don't have to give a bunch of spaces. Num1 star star num2. All right, so that's the program. If I run this, run module, it's like enter the first number, 2, enter the second number, 3, and hey, the result is 8. And I can rerun this, give it different things. What's 3 to the 7th power? Apparently that's the answer. Okay. So are there any questions about what these lines are doing? We're getting numbers from the user, converting them to the whole numbers that we expected to see so that we can do math with those. And then we're printing out some computation, the result of some computation. We're good with that? Remember everything we need to remember? All right. So let me show you some cool stuff for the day now. The main topic is a new library in Python. It's called, we used the math library before. We're going to use the turtle library today. And so you can follow this link and get to it, but you can also just search Google Python turtle. And it will, like the first link will have the documentation page for the turtle library. And so what the turtle library can do is it's a way of giving you beautiful canvases to draw upon. So there's a bunch of functions that do cool stuff, and they all work from the perspective of a virtual turtle. It's very odd. So let's talk about that. All right, so here's the metaphor of the turtle library. There is a turtle somewhere, and stuck inside the computer somehow. He lives in there. So here's our little turtle, and I don't know how to, their feet are a little stubby, right? So there's a turtle, and somehow, there's his tail, the turtle got its tail dipped in ink. Okay, and so maybe it's got his tail dipped in blue ink. And the turtle is a trained turtle. He can respond to our commands and move in certain directions and pick his tail up, or put his tail down and start making marks as he walks. Or he can pick his tail up. You can move him, like you can draw dotted lines. You put it down a little bit. So that's pretty cool. So putting the tail down, of course, on the page makes marks, and putting the tail up does not. You can just have him walk around. But yeah, you're commanding a virtual turtle to walk around on the screen, and he will draw things for you. Okay, so it's really cool. Here's a fancy example. We're going to import the turtle library, of course, and tell him to walk around. All right, so I think the first thing that I want to do is draw a square with our turtle. Okay, but it's going to be so cute. All right, let's do a few things. There's a lot of dots involved because we have to import the library, right? I have to say, you can think of the library functions as belonging to the turtle himself or itself. For example, let me just get started. We're gonna make a program that draws a square. Okay, so this is our goal, to draw this square, and we'll figure it out. We'll figure out how to do it right now. Okay, so let me make a new file for all this. We'll call it, I guess, square.py. Save it. Square.py. Don't need that one right now. And so I'm going to import the turtle library. It's going to look a little weird. I'm going to import turtle, and this like births the turtle into existence. It's really weird and cool. And what happens is our little virtual turtle starts out in the middle of the screen, the middle of his little canvas, pointing east or to the right. So one thing you can ask of the turtle is like where he is right now. He starts out in like, there's a coordinate system involved, so he starts out at 0, 0 essentially. And so we can ask him for his position. We can say turtle.position, that gives back the coordinates of where the turtle is right now, and we can like confirm that by going to the library page, like turtle.position. Also turtle.pause for short. It'll give you back the current coordinates of where the turtle is. So let's just print out where the turtle is just to confirm that like we understand he's going to be at 0, 0 at the start. So let's print out the turtle's position. Print turtle.position. All right. So print the coordinates. Well, if I run this is the little screen where the turtle lives. So we also have the output window. The REPL's still there, but here it is, printing 0, 0. That's where the turtle lives right now at the start of the program. And here's the tiny turtle. By default, he is shaped as an arrow for no good reason. We're going to change that in a second. But he's facing right, so that's east. All right, you can face in any direction, just like a scratch sprite. So one thing we can do, I can close this to stop the program, is change the way the turtle looks. So we're going to say turtle dots all over the place. Like we're doing operations on the turtle. Hey turtle, what's your position? We can ask him to move in a second, but let's see. What I'd like to do is show you how to change the look of the turtle. There's a bunch of different functions in this turtle library, one of which is appearance. We have turtle.shape. You can say turtle.shape and give a string describing what shape you want the turtle to be. It can be a default arrow, a turtle, a circle, a square, a triangle, or classic. I guess the default maybe is classic, and that looks like an arrow. So we're going to change the turtle shape to be a turtle. Why not? We can say make the turtle, I don't know why I like to do this, but it's worth it to me, actually look like a turtle. So we're going to say turtle.shape and give the string turtle, if I can spell turtle. So now he's going to look like a turtle when I run this program. So there he is. Little turtle, face into the right. He's so cute. All right. So there's a bunch of different things you can do in the turtle library. Let's talk about a few. You can read about them all on this page, of course, but like some important ones that we're going to need to draw a square right now are going to be turtle.forward. That tells the turtle, hey, move forward by a certain amount in your current direction. Okay, so go forward by a unit amount in your current direction. So let's have the turtle move forward right now. I'll say turtle.forward. Where's the best place to put this? I guess right there. We'll say turtle.forward by 100 units. So what this line is doing is it's saying, hey turtle, Mr. Turtle, please move in your current direction by 100 units. And so since he's facing east or to the right, he's going to move right 100 units and draw a line, because by default his tail is pointed down on the page. So there he goes. You see him? He drew that line. So there he is. He was starting at 0, 0. He moved 100 units apparently to the right, and there he is right now. Cool. If I can rerun this, you can watch him walk kind of quickly though. So that's how that works. And now his position has changed, right? If I ask for the position now, well, it should be like 100, 0, right? Because he started at 0, 0 and moved right. That's in the positive x direction, isn't it? So he started at 0, 0. Now he's at 100, 0. You see that? Any questions about that so far? So it's a cool little library, I think. To draw this, so like here, let's say that's the top of our square. So like here's the square we're about to draw. So we started at 0. I don't know. Maybe we want to do it this way. We started at 0, 0, and then we told him to go forward in his current direction 100 units. So he walked that way, and now he's sitting at 100, 0. Yeah. And so if we made him go forward right now, he'd like go that way. But we kind of want to draw a square, don't we? So we want him to go this way now and draw that part of the square. All right. So we'd like him to turn. We'd like him to turn left by 90 degrees. You see that? So you can do that. There's a turtle.left function. Equivalently, there's also a turtle.right. And you say turtle.left and a degree amount. We'd like the turtle to turn left by 90 degrees so he can start walking that way. Yeah. So that was 100 that way. We'd like to go 100 this way. And so let's make him turn left 90 degrees right now, because right now he's still facing right, east. Let's make him face north. So we'll say turn left 90 degrees with the turtle.left function. Turtle.left 90. It's an angle by default in degrees. So I run this. Do you see how now he is facing upwards, facing north? So now if we had him go forward by 100 units, he'd walk in that direction, and he'd get to, what would this be? This would be 100, 100. Let's have him do that now. Move in your current direction again. Go forward 100 units, Mr. Turtle. So if I save this, here's the full program, by the way. Rerun it. There we go. Look at him. And now again we have the same problem. Right now he's facing north. We'd like to turn him left again so he can draw the top part of the square. Yeah. So again, same thing. We want to move him, change his direction to be going this way so we can make him go forward. Yeah. So I'll say turtle.left again by 90. See how he needs to turn left 90 degrees to go in the direction I'd like him to go to draw this square. So turn left 90. Boop. If I rerun this with F5, see now he's ready. He's ready to go forward again, and it'll do the right thing. So let's have him go forward now. Forward 100 units again. If we want a square, it's got to be the same amount in each direction, right? So there's that one. Boop. And then, let's see here. And then we have the same problem all over again. I think you get the idea. Now he's sitting at 0, 100. This was another 100 units that I went. He's at 0, 100 right now. We need to, he's facing this way. We need to turn him left again 90 degrees to get him going that way. All right, so it's again, turn left 90 and go forward 100. He'll be walking downwards that last time. And that'll be that. So it's another one of these. Left 90, forward 100. You can see how you kind of could have done this in a loop if you knew how to do loops in Python. Boop, boop, boop. So there he is. We drew a square. And this is the code that did it. Are there any questions about that? It's so cute. It's such a fun metaphor, I think. All right. So, what I'd like you to do now, let me give you this code. What's the best way that I can do this for you? I can give it to you in the code from class. Let me just do that really quick. So if you'd like this code, I'm going to give you a question that involves the code. So please, if you haven't copied it down, you can go to the code from class, just click on any programming lecture, or go up here, code from class, CSCI 1. But let me give you this code really quick. Boop. There, now you have it. It's on the code from class page for lecture 14 folder. You have my square.py. So take it now, and here's what I'd like you to do. I'll keep it up as I show you this as well. But I've shared my code with you. I'd like you to draw a second square. So I've got the first one. Go and draw another square somewhere else. Go down here, draw a square. Or maybe you can be fancy and draw a square in the middle, or a tiny one up here. Pick a new spot for your square and go there and draw it. All right? Right now, the turtle by default has his tail down, he's facing right now downwards with his tail down, right? So if you made him go forward right now, if this was the original square, if you went forwards, he would make a mark. If you want him to just move and not make a mark, you got to pick his tail up, and that's turtle.up to pick his tail up. Then you can move him around, And then you can say turtle dot down again once you're ready to draw your square. Turtle dot down. But give that a try. Try to draw another square somewhere. Another helpful thing that you can do, like once you're in position, turtle dot set heading changes where he's facing. So if you set the heading to 0 degrees, that's facing east. If you set the heading to 90 degrees, that's facing north. If you set the heading to 180, just call it 180 or something, that faces him left, and then 270 is down. Okay, so yeah, try to like pick the tail up, move the turtle somewhere else, put the tail back down, and draw a square there of any size. Okay, so take my code and try to do that. Whee. So here's like the relevant code. Whee. Bunch of lefts, forwards, and 90s. Yeah, take a few minutes to try that, help each other, and then we'll move on. Try to do it without that first. You can draw extra lines, but right now, like the turtle's facing downwards. Right there. Oh, you're in the rebel right now. You have to make a new farm. Oh, yeah, what's that? We did it last time. If that was too easy, you can always search for how to change the color of your lines, how to fill in your squares. That's some fun stuff. have about another minute or so to play around, and then I'll show you one way. The definition is biblical.
Does it really like space everything out? Just so it looks cleaner?
Yeah. There's no need to do it, but I do it so you can follow along easier. All right. So next, let me show you one way to do it. So right now, if I ask the turtle to move forward, so let's section this off. Let's draw a second square. Whee! So if we do it this way, where do I want to draw my square? I don't know. I can draw it to the right, maybe. That would be fun. Like draw the square over here, maybe. Because right now, if I ask the turtle to go forward, turtle dot forward by like 150 or something, he's gonna go that way, and he's gonna make a mark too. So that we don't want any of that. So let's figure that out first. I'm gonna comment out this line so that it doesn't work right now. It doesn't happen. Instead, let's draw a new square to the right. I'll do that. Turtle dot set heading. Instead of having to like fiddle with like turn left, turn right, you can just be like immediately turn yourself facing east. So that's turtle dot set heading. 0 will face you east. So I run that. Boop. Oh, and by the way, if you want to do things faster, you can change the speed of the turtle. You can say it's it's turtle dot speed. I don't think I showed you that. And you give like there's a bunch of different things in the documentation that you could give to set the speeds. Like you give a number from like 0 through 10. You can also just say turtle.speed and give a string. Turtle.speed fast. That's the thing. So make the turtle go fast. So now when I rerun all this, like it'll happen quicker. There it went. So now if I make him go forward, again 150, he'll make a mark. So we don't want that. Like get him into position, but don't make a mark. So before we do this, let's have the turtle pick his tail up. So turtle.up, pick your tail up. And so do you see how now, with the tail up and moving to the right, forward 150, now he didn't make a mark. And now we're in the spot where we want to make our square, so we'll have him put his tail back down. All right, so we'll say turtle.down. Put your tail down. Okay. And now let's say that this is where I want to draw my square. And I'll draw a little tiny square. I'll say turtle dot forward like 25, turtle dot left 90. And I'll just keep repeating that, right? Because that's like the bottom part. This is going to be the right side. You can kind of see how it's getting. Oops. See how it's being built. There it went. And I'll just do that 2 more times. Boop, boop. Don't really need the left 90 at the end. And yeah, there's my second square. Boop. So small. Any questions about how I did that? Let me get something similar. That's pretty fun, I hope. Just think of all the possibilities. So that's the square example. Let's do a different shape. Let's make a triangle. Let's do an equilateral triangle. All right. So now I have to worry about it's not 90 degrees anymore, right? So we have to like pick angles. We have to worry about things. So it's an equilateral triangle. We have to pick like how big we want it to be. This is how it'll look. Let me draw my best straight line. That and like all these, and then like go here and go up to here. You have to think about the order now with the turtle library. That's kind of what we want to draw. And so let's say like, what does it mean to be an equilateral triangle? Every side, well, every angle is the same, right? All these angles are the same angle. What would make that? What's the angle of every angle in the equilateral triangle? Do we remember? It's 60, yeah. It's 180 over 3 because they have to share the same amount. It has to add up to 180. And then every side length must also be the same. You're kind of, that's forced by the angle being the same, but you still got to pick one. And so let's say we want a width 200 at the base equilateral triangle. Okay? And we'll start it at 0, 0. Okay, so we know how to do this one. We know how to make this side right here. So let's do that. Dun, dun, dun. Let's make a new file. Instead of square.py, I'll call it, I guess, triangle.py. Remember to never save your files. Did I say this somewhere? Remember to never save your files as the name of a library.py. Don't save it math.py. Don't call your file turtle.py, because then it lost the turtle library. Because the secret turtle library somewhere is called turtle.py somewhere. That's where it's looking for that. You lose it if you name your own file that. Okay. So remember to never do that. And now I'll make a new file. I'll call it triangle.py. And I don't know, let's do most of all this the same. And then we want to go forward by 200, right? 200. We're going forward by 200 units. Okay? So that should do this bottom part, this bottom little line right here. It'll be a bit bigger than the square was. If I run this, save and I run it. So run module, or just typing F5 will do it. So there he goes, to the right there. And now we got to move him that way. So like he needs to turn left, right? He needs to turn left. This is like he's facing this way. You got to turn him to the left, and you might think like these are 60 degrees, right? You might think that we just need to turn him left by 60 degrees. That is actually not true. Let me show that to you. So if we say turtle.left by 60 degrees, because that's like what the angle is for that triangle, right? Turtle.left 60, and then like he should be ready, right, to go this way and go forward by 200 again. Watch what happens when I do that. Turtle.forward 200. He went off weird. Huh. So he didn't turn enough to the left. You see that? 60 wasn't enough. What was the problem? Let's look at that. We want him to turn this way, right? This amount. This amount. And like we want him to end up with 60 over here. And this is a straight line. We're kind of cutting through it. Remember your geometry class? Like if I want him to turn this amount, it's this angle. What is this angle? Yeah, it's 180 minus 60. Do we see that? That's the secret. So this needs to be, don't turn left by 180, or don't turn left by 60, turn left by 180 minus 60. So whatever that, I don't know, it's just like complementary angle, supplementary, I forget the word, but there's a word there. That's what we want, all right? So don't turn left by 60. You can be like, you can hard code, yeah, turn left by 120, or you can be lazy, leave it to Python. It's like, I need to turn left by whatever 180 minus 60 is, that amount. That's the magic of programming. And there he is doing the right thing. And so I think for the same reason, you can see he needs to turn left by that same degree, by 120 again, and then go forward 200 once more. Okay? So I just do that twice more. There it goes. And so that leaves me with a cute little triangle. Does it make sense why that is the code that we need? Very pretty. So if we are good with this one, I'll give you all this code again to play around. It's really fun to play around with this kind of stuff. I think you can see the potential it has. I'll ask you to do that in your next programming assignment too. Let's draw my initials. I'm going to ask you to draw your initials plus your graduation year in your next programming assignment, but let me give you a sneak peek of that. I'll draw my initials using the turtle library. All right, so like the L is easy, that's like a square almost. But the N in my last name, that is a bit difficult. So like this is what I want to do. Okay? This is what I would like to draw. An L with the turtle, and then like an N. I want to draw my initials, please. Whee! And so I have to kind of pick a lot of stuff. I have to pre-plan all this up front. I got to pick like how wide and how tall should my initials be? Like what's the spacing? What do you do? Okay. So that will be fun. So let's say that like we need to start maybe right here. We'll get into position there. And then we'll like start drawing the L. Let's say that our character should be, at least the L character should be 200 tall by like 125 wide. And let's say we want to do the same for the N. It's like also 200 tall, also 125 wide. And then we also need to we're going to need to skip across a gap here. Like what should the gap size be between these two letters? We have to plan all that. Yeah? And let's plan it to be a number that worked last time was 40 units. Okay? So it's also 200 tall, the N. Okay, so that's your blueprint. Let's go off and ask the turtle to do those things. Okay, so all right, the L is easy. Let's get into position to do this this L. Let's say that we want to let's say that this is like our 0, 0 right here, 0, 0. And I'd like to draw the L and get into position up here. I'll start here, move that way, then turn and go that way for the L. Okay. So I think that's the game plan. So let's get started with that. I'll make a new called initials.py. I'll steal all this though. Steal. I'll save it as initials.py. You can try to draw your own initials if you'd like right now, but I'm about to show you something weird that's going to happen for the end, so you might want to pay attention to mine. So here's all this stuff from the triangle. Let's get rid of what we don't need. Let's make the turtle go slow, actually. So I'm not going to have him go fast. I'm going to comment out this line so that it takes no effect. Okay? And then, essentially, before I do anything, I want to get the turtle into position to draw the L. I want to start here. This turtle starts his life at 0, 0. I want to move up here first so that I can then go in that order and draw an L like you would with a pencil. So let's do that. Let's get him up. So he starts out here. I want to move him up first, and then he's ready to draw. So move up by 200. Okay. So I'll put him in the right spot. So get the turtle into position first, and so that's going to involve picking up his tail and pointing him upwards. Turtle.set heading will do that, or a left 180 would do it as well. So set heading 180. 0 is right, 180 is up. And so now he's facing in the right way with his tail upwards. Oh, sorry. Oh, gosh, no. Maybe I don't want to start that at 0, 0. I guess I did this something different last semester. So I kind of want this centered on the screen, so I'm going to have the turtle go left a little bit, actually. So sorry, 90 was up. Let's go 180 and make him go backwards a little bit. So let's not have this be 0, 0. I'll fix what I want this to be. Let's say I want this to start working backwards from my example that I pre-planned. Let's say that I'd like this to be at negative 200, 0. How about that? Okay, I think that's what I want. Because then this would be negative 200. Let's see. Something else. We'll figure this out later. But that could be negative 200, 0. So let's move him there first, because I wanted to draw the left over here. So I need to move the turtle left a little bit to draw the L over there. Okay. So let's have him go forward now. Turtle.forward by the 200 that I said there. So there, now he's over there, and I want to draw my L and draw my N. I kind of want that to be maybe centered on the screen, let's say. So like, let's see, how do we want to do this? So maybe, I think I lied again actually. If I want to do it this way, forget I ever used coordinates. Let's just like move them over and move them up a little bit until it looks right. I think that's the goal here. All right. So let's tell him, the turtle's right here, let's move him upwards a little bit to start the L, all right, because I want to get him into position. So let's say I could do a set heading 90. I could also say turn right 90 to move to like face upwards. Let's do that. Turtle dot right 90, let's say. So like, let's get him into a good looking spot and then like move him up a little bit. Let's say turtle dot forward 100. So it's kind of centered because the height of the letters will be 200. So I think that's a good starting spot for the turtle. I'll draw an L, length 200, then an N. Okay. So where did we just put him actually? We went left 200 and then up 100. So I guess we are at right now negative 200, positive 100. That's where we put him. And that's like a nice place because like 0, y equals 0 is in the middle of this and it'll kind of look centered almost. That's kind of maybe a good starting position. Yeah.
Can you get the turtle rotation?
I think so. We had a set heading. I think there's also probably a get heading. We can confirm that heading. So yeah, I think you can definitely set the heading. And it looks like there's no, it's just turtle dot heading, and you can get where he is right now. Yeah, that's a.
That's going to return the number.
I think it'll be degrees. Yeah, just like for set heading, it looked like this. Yeah, 0 is east, just like mathematical degree stuff. 0 is facing right. Yeah, we just put the turtle here, and I think that's a good starting point. And now we can make him face down and draw the L. Okay, so we'll make him face downwards. We also should put his tail down, because now we're actually ready to start making marks. So let me move this up. Well, let's put his tail down now. Turtle dot down, because we're ready to draw. So we're going to draw the L. How do we do it? Well, he's facing up right now. I got to make him face downwards. So we'll say turtle dot set heading, and it was 0, 90, 180, 270 is down. Alright, 270, so now he's facing downwards. And then we're going to make that L of that size that we promised to make it. So we got to go forward down by 200, right? 200 will make it have the side of that length. So go forward by 200, Mr. Turtle. Try to race me if you can. See if you can beat me doing it. Turtle dot forward 200. So that'll draw the correct side of that L. It's nice and centered. And then we gotta like move him. He's facing downward, so we're gonna like turn him left. You see that? Turn left by 90. Because then we can draw this one. So it's like he's facing this way. We need to turn him to the left by 90 degrees. And then go forward 125. Turtle dot left 90. So you see how now he's right. That's the right amount. Now he's in the right spot. Now go forward by the width of what we promised the L to be, and that was 125. Bam! So there's my L. Not too bad. Are there any questions about how this code gave me that, though? Good so far. Alright, so now we want the gap, because we want to like draw the end. We need to get to here, but we don't want to make any marks as we get to there. So I want to go forward by 40, because he is in the right direction right now. I want to go forward by 40, but I need to get some space in between. So this is space in between letters. We need to draw that now. So if I just say turtle dot forward by the 40 or whatever I said was the distance in between, he's going to make a mark right now because his tail is stuck down. So we got to fix that. So I run this. I made that mark. We want to pick him up before he goes there. Turtle dot up. Then go forward 40. And now we're in the right spot to make the n now, so we can put the tail back down. Okay? So we're here. Now we're ready to put the tail back down. Turtle dot down. And now we are ready to draw that n. Draw the n. Let's make some space so I can show you all this. So, okay, we can do this first part of the n. That's easy. We need to make him face upwards, right? So we can turn him by 90. We could set the heading to 90 as well. So let's just be like turn left by 90 because right now he's facing east. Let's make him face north by turning left 90. Okay. So turtle.left 90. That'll put him in the right spot. There he goes. And we can go up now by 200. That's perfect. So go forward by 200. That's perfect. And that'll be that part of the n. But now we have an interesting predicament at our disposal on our hands. So, all right, I need to draw this n. So I need to turn the turtle. The turtle is right here, facing this way right now. I need to get him turned right this way so he's facing this way to go forward by that amount, right? I have two unknowns right now, don't I? I have what in the world is this angle? Yeah. And then I also have, like, how far is this? It's bigger than 200, right? Because it's sideways a little bit. What is this length? Do we have any thoughts about how to get those numbers? You thought you never needed to learn geometry or remember your geometry class. Now you finally do. Yeah, how do you do it?
125 to the power 2, and then you add that to 200 to the power 2.
Yep.
And then you take the square root of that result.
Very good. So that's the Pythagorean theorem, isn't it? This is a right triangle. This part of the n. Right here. It's a right triangle. Do we see it? Disgusting. But we can solve for what we need because of that. So not only do we know L, right? We can figure out L from the Pythagorean theorem. We have that L squared is equal to 125 squared plus 200 squared, right? 125 squared plus 200 squared. So we know that. To get just L by itself, we can take square roots of both sides. Square root of both sides will cancel out that stuff. So that's L. We can use the math library for that. And then also, how do we get this angle? This is trigonometry now. Ooh. So we have every length now because we know how to solve for L. But I guess the original lengths that we had were the opposite and the adjacent. Yes. So what do I have that relates those in angles? That's your tangent, right? So I know whatever this question mark is, the tangent of it is opposite over adjacent, right? 125 over 200. You thought you never needed to remember this. Now it's finally useful knowledge. 125 over 200. And so we can solve for that angle, can't we? This question mark is equal to the inverse tangent. If you just take the inverse tangent of both sides, you get the question mark is equal to the inverse tangent of 125 over 200. And this answer, we're going to get it back. There is an inverse tangent in the math library. Like your calculator can do that, but everybody's calculator gives it back to you, not in degrees, but in radians, right? And the turtle turns left and right in degrees. So we need to convert that question mark in radians to degrees before we use it. Okay? Any questions about that? So that's the math that we have to do to draw this in. See that? A little complicated. So let's import the math library. Remember that the math library exists. Python math. That will give us the things we need. That gives us square roots. So SQRT exists there. And then the inverse tangent is also called the arctangent. So we say math.atan to get the inverse tangent of something. And to convert from radians to degrees, we're going to say math.degrees. That converts from radians to degrees. All those things exist in the math library. Okay? So let's make this happen. All right, we need I guess we need the angle first before we draw. The L is secondary, I guess. So let's get this angle first. Get this question mark. So we're in initials.py. Let's make this small so that like we can see our work. So, all right. Oops. I need to first import the math library. So I'll go up here, just like import total, I'll say import math. Now I have all that stuff at my disposal. And then let's get that angle. So the angle, we can just make a variable. The angle that we need right now, angle, whatever it is, it's math dot, it's the inverse tangent, right? Inverse tangent of 125 over 200. So that's math dot atan, inverse tangent, arctangent, of 125 over 200, the slashes for division, right? And this gives me back the angle, I can save it, in radians. I want to use it in degrees, though, because that's what the turtle likes. So you can take this and shove it right into the math.degrees function that takes radians and converts to degrees. So I can say math.degrees, whatever this became, right? It'll take whatever this was, computed to be, and converts it from radians back to degrees, and then I'm shoving that into the angle variable. Now I can use that, okay? And so just like for the triangle, when we drew it, because this really is a part of a triangle, I want to turn the turtle right, not by that angle, but by 180 minus that angle. Do we see it? I want to turn right by 180 minus that angle that we just solved for. And that is what we needed all along. So turtle.right, 180 minus angle. And then let's see if he looks lined up properly. He sure does. All right, and then we can go forward by however we need to go forward. It's the L amount, yeah? So we'll say go forward now. By that L, we have to solve for L now. So L is equal to the square root, math.sqrt, of 125 squared plus 200 squared. Star star for power of, yeah? So there's L, and I can say math.forward by L. All right, it kind of looks like a 1 in this font. It's an L. That's the variable L. So go forward by L, please. Whatever that was. We don't have to care about knowing what it was. Python will just solve for it for us. Oh, wait. I guess I did something wrong. Sorry. So not math.forward. Sorry, turtle.forward. Turtle.forward. Excuse me. There it goes. Up. There we go. Perfect. And then now we need to like move him up, face him upwards. Yeah. So again, you could be like, you know how to face them upwards, that's fine. You can be like, set heading immediately to 90. That's one way you could do it. Or, these are similar triangles. This is the same, not drawn to scale, but it's the same angle right there. And so you could also just be like, turn left by 180 minus angle. That will also work, and I'll just show that to you to prove it. Prove a point. So that's a thing you could do. They are the same triangle, essentially, so it's just turtle.left this time by that amount. And that really will face them back exactly upwards. Boop. You could also have done set heading. And then go forward 200, finally, to draw the last part of the end. That was a lot of work. But we did it. There's my initials on the big screen. Any questions about what we needed to get that up in there? Beautiful. So here's the final code for the end part. Are there any questions about what we did? You'll have all this code. Definitely study it. Great example of a lot of things. Are there any questions about this code for now? Probably something we just want to stare at for a while, maybe. But if we're good, I want to show you, it's like, if you've taken a calculus class, you know how you have to learn about limits. Just use those to find derivatives before you learn the trick that's the easy way. There was an easy way to draw this out. Okay, I had to show you the hard way first so that you understand and like appreciate it. But you can cheat. There's a turtle.goto that just warps the turtle somewhere. So you could have done it much easier like that by just picking points. But I'll show you that next time. If you say turtle.goto, like you give two coordinates, like turtle.goto 0, 0, regardless of the turtle's direction, he will just warp there. Watch. Turtle.goto 0, 0 after the end is drawn. Whee! So there he goes. He just warped to 0, 0, even though he's facing upwards the whole time. So that's the thing. I'll comment that out so that you have the original code, but that would have been easier. But then I couldn't have shown you all these fun library functions, so what was the point? So you can totally cheat, now you know, but I encourage you to get practice doing it the hard way. So if we're good with all of this, are we? I want to give you your next programming assignment, because you got one due. Alright, so we got this guy. Scrolling down. Here we are. Programming assignment 5. It's our 6th programming assignment since we started at 0, right? So what I'd like you to do is draw, in addition to your initials, so do that, like I did today, also draw the year that you intend to graduate, either from here or from a 4-year college, whatever you want. So don't just draw your initials like I did. Also draw your graduation year. You can draw like just the last 2 digits is fine. So, for example, if it was me doing this program, I graduated in 2020. So I would make a program that draws LN20 somewhere. All right, could be in any order. Like the LN could be above, the 20 could be below, it could be to the right. Doesn't matter where you put the things. Just put all those symbols on the screen somewhere. All right. So you don't have to use fancy angles if you're having trouble with that. Also, if you have like a C or like a G or something curvy in your initials, or even in numbers that you want to draw, you can just make them like you would see on like a digital display. Like, could it be straight lines? It's totally fine. Don't have to try too hard. There is a way to draw curved lines with the Turtle library. There's a dot circle to draw portions of a circle, or ovals. Give that a try if you're interested. If you are one of my advanced students, I'm going to force you to do it that way probably. So this is just my initials. Remember to add like your graduation year. So I should have put like 20 somewhere here. That's what you're doing. Initials plus graduation year. Does that make sense? So use my example.
That's for everybody?
Yeah, I'm about to say that. So don't forget your 2 digits, the last 2 digits of the year you intend to graduate. So like 24 or 28, I don't know, whatever you want. And then give me a video. Give me a video of your code running. Explain your code to me. I want to hear your voice, right? Doesn't have to be long because it's just like I'm doing these things. Here's the code for the L. Here's the code for the N, the 2, the 0. Here's doing those things. It's doing it in that order. Here's how I solve for this stuff. So it doesn't have to be long, but that's what I want to see. Okay? Questions about that? If you're one of my advanced students who has programmed before, finally, I would like you from now on to do the Python assignments. I want you to learn Python too. All right? So I want you, though, to go above and beyond the basic requirements for everybody else in accordance with your skill level, please. So, like, if you have, like, for example, your graduation year is probably going to have a 2 in it somewhere. Make a cute-looking 2 with a curve, please. Figure that out. Question? Yeah. Oh, sure. I can answer it after class then, if you want to wait. But yeah, you specifically make a fancy one. So that's from now on, just do the Python stuff, please. So yeah, we're all doing this one now. Any questions about that? So yeah, this will be due in a week, I guess. Thursday, so I gave it to you a little bit early, so that's nice. Yeah, initials plus your graduation year, please. Just the last 2 digits of the year you intend to graduate. So I think, yeah, that's all that I wanted to say about that. Does it make enough sense? Give me a video as usual. And yeah, I think that is officially all that I have for us today. The rest of the time is yours to get started on that or ask me any questions that you